They hide where no telescope dares to look behind the sun's blinding glare. Now astronomers have found one massive asteroid that could shatter continents if it struck Earth.
The first signal appeared deep within NASA's Planetary Defense Monitoring Network, a faint streak across the automated tracking feed that didn't match the motion of any known asteroid or comet. Within seconds, algorithms cross-referenced it against all catalog solar system objects and came up empty. The anomaly was moving too fast, cutting through the inner solar system on a hyperbolic trajectory, an unmistakable signature of an interstellar visitor. The designation was confirmed soon after. 3I Atlas, the third known interstellar object ever detected passing through our cosmic neighborhood. It wasn't just another rock hurtling through space. It was something arriving from beyond the solar system's gravitational reach, a messenger from another star system. For NASA's Planetary Defense Coordination Office, this was the moment the global monitoring network had been built for. The full system was activated, drawing together radar arrays, optical observatories, and deep space sensors in an unprecedented effort to study and ensure the safety of Earth from this mysterious traveler. Before we start, please don't forget to like and subscribe to our channel for more updates. The Planetary Defense Network had evolved from decades of careful planning and technological refinement. Originally focused on detecting near-Earth objects, asteroids and comets that could pose an impact risk, it had expanded into a complex web of ground-based telescopes, space-based observatories, and data analysis hubs capable of scanning millions of celestial bodies every night. When 3I Atlas appeared, the network immediately switched into coordinated tracking mode. Automated systems sent alerts to observatories across the globe, from the Pan-STARRS telescope in Hawaii to the Vera C. Rubin Observatory in Chile, while NASA's Deep Space Network adjusted its communication schedule to accommodate data transmission from spacecraft that could pivot sensors toward the target. The object's velocity was extraordinary, tens of kilometers per second relative to the Sun, indicating it wasn't bound by solar gravity. Its trajectory suggested a path slicing through the inner solar system, briefly skimming past Mars's orbit before heading toward the outer regions again. The speed alone made 3I Atlas an object of intense scientific curiosity and potential concern. NASA's decision to activate the entire Planetary Defense Network underscored the seriousness with which the agency regarded unknown interstellar objects. Unlike asteroids that had predictable orbits and decades of observation data, 3I Atlas was a stranger from another system. No one could say with certainty what it was made of, how stable it was, or whether it might fragment as it passed near the Sun. Such uncertainties were enough to justify a full-scale monitoring campaign. Within hours, radar facilities like Goldstone and Arecibo's successor installations began bouncing radio waves off the object to determine its shape and rotation. Infrared telescopes scanned for thermal emissions, hoping to gauge surface composition and reflectivity. The James Webb Space Telescope, though already engaged in its main astrophysics missions, allocated several hours to obtain high-resolution spectra of the body's surface. Every piece of data could reveal whether 3I Atlas was a frozen cometary nucleus, shedding gas and dust, a metallic fragment, or something even more unusual. The object's discovery also triggered an immediate public fascination. Interstellar visitors had always fired the human imagination, but 3I Atlas seemed to arrive during a moment when the world was more prepared to watch and understand. The previous two interstellar bodies, Oumuamua and 2I/Borisov, had already redefined scientists' understanding of what kinds of materials could travel between stars. 3I Atlas, however, was detected earlier in its trajectory than either of its predecessors, giving researchers precious time to observe it up close. Its brightness, motion, and trajectory made it a prime target for the planetary defense community to test its readiness. This was no simulated exercise. The activation of the defense network was real, coordinated across international agencies, including the European Space Agency, Japan's JAXA, and observatories in South America and South Africa. The world space agencies briefly set aside their rivalries to follow this cosmic visitor together, united by both curiosity and caution. As the object came into clearer view, its characteristics defied easy classification. The light curve suggested a tumbling, elongated body, perhaps a few hundred meters in length, reflecting sunlight unevenly as it spun. It did not display the typical tail of an active comet, but faint traces of gas emissions were intermittently detected. indicating pockets of volatile material trapped beneath a crusty exterior. This combination made it appear as a hybrid, a transitional form between an asteroid and a comet, something that might have formed in a distant, cold protoplanetary disk before being ejected into interstellar space millions of years ago. The Planetary Defense Network's spectroscopic data hinted at compounds never before observed in local solar system bodies, including exotic carbon chains and metallic silicates that bore the chemical fingerprints of another sun's light. For NASA, 3I Atlas represented both a scientific opportunity and a practical challenge. The agency's engineers debated whether to attempt a rapid reconnaissance flyby using one of the available deep space probes. Though the object was moving too fast for a traditional interception, conceptual plans were drafted to retask the recently launched probe designed for asteroid deflection experiments. Even a glancing observation from a passing spacecraft could yield invaluable close-up images of a visitor from another star system. The sheer possibility reignited enthusiasm among scientists and policymakers alike for developing agile, long-range interception craft that could respond to transient interstellar phenomena, an idea that had once seemed purely theoretical. Within the planetary defense community, the activation of the network was not merely about this single object, but about refining humanity's readiness for future cosmic encounters. The sensors, algorithms, and rapid response coordination systems that had been tested on asteroids now faced an entirely different scenario. 3I Atlas did not threaten Earth directly. It was projected to pass millions of kilometers away, but the experience illuminated gaps in early detection capability. The fact that the object was only discovered weeks before its closest approach showed how even the most advanced survey systems still struggled with faint, fast-moving intruders from deep space. The incident prompted discussions within NASA about expanding space-based observatories to orbit near Venus or beyond Earth's orbit, where the geometry of sunlight would allow for better detection of dark inbound bodies. The activation also served a symbolic role. It demonstrated that the Planetary Defense Network was no longer a theoretical safeguard, but an operational shield of vigilance spanning the planet. The network linked radar facilities, infrared sensors, optical telescopes, and data centers into a seamless digital web capable of processing terabytes of celestial data in real time. Artificial intelligence algorithms scanned the skies each night, flagging unusual motion patterns or brightness variations for human review. The activation for 3I Atlas tested every layer of that architecture: how quickly alerts propagated, how efficiently data were verified, and how rapidly the scientific community could mobilize resources. Every step was logged, analyzed, and refined. For the engineers behind the system, this was their moment to see the network function exactly as designed, turning the vastness of space into a field under continuous human observation. Beyond the technical implications, the event touched something deeper in the public consciousness. The idea of monitoring a visitor from another star resonated with humanity's oldest questions about origins and cosmic connection. The interstellar object was a fragment from another world, possibly formed around a different sun, carrying with it the chemical story of an alien system. To many astronomers, this was more than an object. It was a sample of another planetary nursery, drifting between stars for eons before entering our view. For a brief span, 3I Atlas became a symbol of both cosmic solitude and interstellar kinship, proof that the materials of life and planets were not confined to one system but scattered across the galaxy. NASA's decision to keep the object under continuous observation also reflected an awareness of the unpredictability of interstellar phenomena. While no threat was apparent, the mere possibility of an unexpected trajectory change due to sublimating gases or rotational instability required constant recalculation. The Planetary Defense Network's modeling teams at the Jet Propulsion Laboratory ran millions of simulations, mapping potential trajectories with supercomputers to ensure that even improbable deviations were understood. Every update was transmitted to observatories worldwide, keeping all parties synchronized. It was a real-time dance of science and vigilance, a demonstration of how far planetary monitoring had evolved from the days when celestial discoveries depended on a single astronomer peering through a telescope. If you like this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us? What are your thoughts on NASA activating its Planetary Defense Network? We want to hear from you. Thank you for watching, and see you next time.